Howdy folks. Today we're going to talk about some more advanced concepts in SQL. That being, we're going to start with foreign keys and then look at table joins, and then we'll see where we go from there. So, before we describe what a foreign key is, I'm going to show you a situation where you might want to have a foreign key. So, let's create ourselves a table. Let's call it user. Okay. User has an ID. Make an integer. We'll make it a, oops, not null. We'll make an auto increment and primary key. So this is the standard way of making it so the ID gets set up. You don't have to pass it in. It auto increments, etc., etc. We're just give a name here. We're gonna make it a varchar and put 50. All right. So let's go into my SQL. All right, and then I'm going to use a database I already have set up. I have no tables here, so I'm going to create my user table. Okay, yes. Okay. Okay, I have a user table. Let's put some data into it. User. Remember, I don't have to put the ID because that is an auto increment. I should have made the name not null, but that's okay. Let's put a name in there for Bob from user, and Bob has an ID of 1. Cool. Let's make another table, address. So we want to keep track of addresses that people have in our system. Okay. No, I'm going to put another ID on it. It's pretty common to just have an ID field on every table, just so that you have a unique number to identify the row by, which can come in handy in a lot of ways. All right, so let's see. What are the important parts of address? We have the street. Let's make that a varchar. We have the city. Let's make that a slightly smaller varchar. We have the state. I'm going to make that a 2. And I'm just assuming in this case this is a US address because this is where I'm based. So I'm not going to put a country, but if you're doing a real address table, you probably put a country field in here. And zip, I'm just going to do an int for the zip. All right. And then we need a way to tie that address to the user, right? And so here's where we get an important distinction. So there's 3 ways to connect tables together. There's what we call a one-to-one mapping, where one row on table A maps to one row on table B and never more. So I could say if a user is only allowed to have one address, I could call that a one-to-one relationship. If a user can have multiple addresses, that's a one-to-many. So one user has multiple addresses, but one address only belongs to one user, right? So from the addresses point of view, it's a many-to-one relationship. So the address itself only belongs to one user, but a user could have multiple addresses. So that's what we're looking at here. We want a user to be able to have multiple addresses. If it was a one-to-one relationship, I can actually put an address field on the user table because I know that user is only going to ever have one address. But this is a one-to-many, which means that the user could have multiple addresses, which means I can't put a single field on the user table that captures an address ID because there could be multiple. So what I do instead is the user is actually not going to have information about what address belongs to it. Instead, the address is going to know what user it belongs to. So I'm going to put user ID on this table. Oops, I don't want to save that. So why do I do that? Well, I do that because each address only has one user ID that it belongs to. So this is the easy way to set that up. Each field only needs to have one value. And so I could add multiple addresses, each one with user ID of 1, let's say, and each one of those would correlate to Bob because that matches their user ID. So sometimes in SQL, if you're doing a many-to-one relationship, the field doesn't necessarily go on the table that is the owner of that relationship or is the one in that relationship. It goes on the table that is the many for that particular reason. All right, so let's create that table. And then let's insert an address. Okay, street, city, state, zip, user ID. And then we'll say values. Okay. Street, city, oopsie. California, And the zip is going to be just some bogus zip. And I'm going to give ID 1 because that's the user ID and that matches with user ID 1. So I'm going to insert that. We can insert a second row as well. Let's do other city, some other street. But you notice I'm going to leave that user ID the same. So both of these addresses belong to that user. So if I want to get all the addresses for that user from address, oops, where user ID equals 1. And you can see now I get both addresses. That is the many. So if I need to get the multiple rows that correspond to that one ID, I can do it like this. Okay, so that's how we set up that relationship. So let's talk about a foreign key and why we want a foreign key. So we've got this relationship where this user ID maps to this row here. So that's great, but let's say I delete that user. Where 1. Okay, so now if I select from user, there's nothing in there. But if I select star from address with that user ID, I still get rows. And here's the problem now. This is what we call orphaned data. These addresses no longer belong to any valid user in the system. They've been removed. So we don't like this because depending on our application setup, it's very likely that these rows of data can never be accessed again by any legitimate means because the user that had permission to access them is gone. And in most cases, even in administration panels, we're looking up the user first and then we're seeing the list of addresses they have. Whereas these two addresses here, these are tied to a user ID that's gone, so we can never access them again. We don't like that. So how do we fix that issue? Well, we fix that issue by using a foreign key. So let's take a look at what that would look like. I'm going to drop the address table. Drop table. There we go. So this user ID is fine as a key. It's a good field, but we want to actually attach it to this ID. And what that gives us a number of benefits. So let me show you how you do that. First of all, you start off with every foreign key and you say foreign key, and then parenthesis. The parenthesis, like any key, is going to be a list of fields. In this case, we only want to do one field because there's only one field that belongs to this table. So we're going to say user ID. This is the field on my table, the address table, on the table I'm accessing. Okay? So whatever goes inside these first parentheses needs to be one of these fields. The next is I need to tell SQL what foreign field in another table this needs to hook up to. So to do that, I can say references. Then I give the table name of the second table I want to connect to, which is user. Then I need to give the field name of the column in that table that I want to connect to, which is ID. So what that means is user ID now gets a mapping to here, which is this field. If I call this ID blah, I would put ID blah here. So this is not the ID of the address table. This is the ID of the user table. All right. And that's important. So what that does is that will create a connection between those two fields. That means any data that exists that we try to put into user ID must also exist in some row in the user table under this field. So let's put that in here. Let's create that table. All right, and just to make sure it works, I'm going to say show create table address. And you can see there it's added that constraint. It's given it a random name. Foreign key user ID references user ID. All right, so now I'm going to insert my user Bob back into the table. Okay. It's now user ID 2. Totally fine. Let's go and insert into this address, this old address back here. Well, that fails. It says cannot add or update a child row. A foreign key constraint fails. Why did that happen? Well, I gave it a user ID of 1. but that user ID doesn't exist in the user table. Instead, there's user ID 2. Why does that happen? Well, when you delete a row in SQL, that doesn't decrement the auto increment value. That continues to go up. So the previous row was 1, and so the new row is 2. That's just how auto increment works. So let me change that to 2. Okay, pop that in there. Okay, and that works now. That works because that address has the correct ID that matches in here. Okay, so if I look at address, it doesn't seem any different from this point of view. And as far as SQL is concerned, for the select, this is the same as what we had before. But now, not only is there this special thing where I can't insert a user ID that doesn't exist, which is very valuable because remember, if we get a user ID in here that doesn't exist, this is a dead row. We can never access it again. Let's see what happens if I try to delete Bob again. It gives me another error. And it says, hey, I can't delete or update a parent row. Foreign key constraint fails. What that's telling me is it's saying, hey, you have foreign keys that are relying on your ID, and if I was to allow you to delete this row, they would be dangling. And I don't want that. That's not okay because you've specifically said there's this constraint on it. So now it doesn't allow us to delete this because that address row is still in there. Which is, all well and good, but maybe we actually want to be able to delete the user. We just don't want the address row to stick around. So what we could do is we could actually go and we could say manually, okay, select star from address where user ID equals 2. We see, okay, it's ID 2. Delete from address where ID equals 2. And then we delete from user again, and it's totally fine because there's no longer that row. We just got rid of it. That's a bit of a pain, and maybe we want that to happen automatically. So as it so happens, there is a way that SQL can do that. So there's, after our foreign key here, references, we can say on delete. So on delete is what tells SQL, hey, if the foreign key row does get deleted, what should I do? By default, it throws an error like we saw. It says can't delete or update a parent row. There's a couple things we could do here. One of them is we could say on delete null. On delete null says, hey, as soon as that parent row gets deleted, nullify the user ID. Which would make sense because now it's no longer pointing to a user ID that doesn't exist. We don't really want to do that because we have not null here, and also that's still dangling. The other thing we can do is on delete cascade. Now, what does that do? Well, cascade means continue to cascade the change down the tree. So if I delete user with an ID that's in the address table under user ID, it will also delete the address. So let's take a look at how that works. So we're going to drop the table and recreate it. All right. Now I'm going to insert my user again. All right, and then I'm going to change this to 3 and insert that row, which is fine because that's it. I'm just going to insert a second row as well. Okay, so let's take a look at user and address. Okay, so now we have this user 3, name is Bob. We have these 2 addresses, which I know they're identical, but their IDs are different. So they are different rows. And we have that user ID. So now if I delete from user where ID equals 3, you notice it didn't complain. It didn't say, hey, there's a foreign key issue. Why is that? Did we break something? Well, no. If I run those selects again, so let's do the select from user first. It's empty. But if I select from address now, whoops, I'm just going to select here. It's also empty because those deletes cascaded down into the address table. And what does this mean? This means that we have no dangling addresses. We don't have to worry about cleaning up when we delete a user because the foreign key system meant that MySQL did it for us. So that's how foreign keys work. They're quite useful. There's another way of handling this. So this was the one-to-many. The other kind of relationship that we can have is a many-to-many relationship. So for example, let's say a user can purchase many products. So let's take a look at our product table. Product, we're going to have an ID, as usual, primary key. And we're just going to do for now product name and 100 null and then a price. All right. So with a product, products can be purchased by multiple users, right? So we don't want to put a user ID on here because if we put one user ID, that means that the product can only be bought by one user, and that's not really how we want that to work. On the other hand, a user can buy more than one product, so we don't really want to put a product ID in the user table because that means we can only purchase one product. We have a many-to-many relationship. User can purchase many products or have many products associated with them. A product can be purchased by many users. So what do we do in this case? If we have a many-to-many, we have to create what is called a pivot table. Okay, so let's create this product to start off with. Let's insert one. Product name price values. All right, and let's insert that in there. So what would a pivot table do? I'm actually going to take this address stuff and I'm going to move it down because, oops. A pivot table is what we call a table that joins two other tables together that have a many-to-many relationship. So let's take a look at what that would look like. I'm going to call it purchases. Purchases. It's going to have an ID, as every table should. Okay, so the purchase, it may have some metadata on it, like when did you make the purchase? Did you have a discount? How much did you actually pay? But two things are important between it. One is the user ID of who made the purchase, and the other is the product ID of what product was purchased. And in this case, we're actually going to have two foreign keys. So let's set up one foreign key on user ID, references user ID. On delete, well, let's not allow this to be deleted because deleting purchases is not something we necessarily want to do. And then another foreign key on product ID, references product, the product table and the ID there, and references. Okay, so let's create purchases table. Okay, so now we've got a product, right? And we've got, well, we don't have a user. Let's put a user in here. So now let's insert into the purchases table. So we need the user ID, product ID. And you can see now how this user ID and product ID, neither of these have to be distinct on their, or they're not distinct, sorry, they're not unique. So a user can purchase a product multiple times. They could purchase multiple different products. A product could be purchased by multiple different users because we have these two fields in a row that can be set up that way. So let's set up this way. Let's actually just change all these keys, right? So if I do this, it's going to complain. It says, hey, the purchases or the references for the user is wrong. Well, that's because we're doing user 4. Let's try that. And it says, okay, now the product is wrong. So this is now tied to both tables with a foreign key. I do that insert, we're fine. So I can select from purchases here. Now, if I try to delete my product from product where ID equals 1, you see it fails because the purchases table won't let it be deleted. Same with the user. So this is how we do a many-to-many relationship, is with the pivot table. And again, there can be other fields in here, but the main ones are these IDs. All right, so with foreign keys out of the way, let's talk a little bit about joining. So there's actually, and let me see if I can find it in here. there's a great diagram for this that is in Stack Overflow. Well, it's somewhere, but I don't know who actually created it first. So this is SQL joins. So this is a really great diagram of how these work. Table A and table B. If you're doing an inner join, then it means that it's only rows that match each other. This is the default. Inner joins are the default of what shows up, I believe. A left join is everything in A and then data in B if we need it. Right join is the other way. We have these other things. There's outer joins, which is just everything. So I'm going to put this aside for a minute, and then let's take a look at our actual, how we want to join stuff. So when might we want to do this? Well, let's say if we want to get all the addresses for a user, right? Along with the user data that's associated with them. So what we could do is we could just say select star from user, or and then, well, let's actually do this over here. Select star from user, and then we see user 4. I don't actually have any addresses for user 4, so let's insert some. So we could say select star from addresses. This is where user ID equals 4. Oops, it's address, not addresses. Okay, but let's say we want the username in this as well, the name of our user, and just like maybe the city that they're in, or the city of their addresses. So what we can do is we say, okay, select user.name from user. Okay, then we say join addresses, or address. If we just do that, well, we get Bob. We get Bob twice. How come? Well, if we do a star here, where star does everything, you can see we've got the ID, we've got the name. These are from the user table. Then we've got ID, street, city, state, zip, user ID. These are from the address table. So what a join does is it basically combines our two tables together. I'm actually going to make another user just so that we have a good example of this. Let's make a user called Kenny. Okay. All right, let's add Kenny, and let's give Kenny an address. And let's say Kenny lives next to Bob downtown. All right. And then if we run that query again with the join, now you can see we've got some interesting data. Kenny shows up 3 times with ID 5, and Bob shows up 3 times. So basically, what has happened is every single row in the address table has been combined with every single row in the user table. That's what a join does. It basically just smashes tables together and combines all their rows. So we had 2 rows in the user table and 3 rows in the address table. So now we've got 6 rows. Not the most useful thing though, because now Bob is hooked up with this address that we know belongs to Kenny, and Kenny is hooked up with 2 of Bob's addresses. We need to filter this. So we can say, okay, where address dot user, well, just say user ID. User ID equals ID, right? Let's run that. Well, MySQL says column ID is ambiguous. What does that mean? It means right here, user ID, there's only one table in this row that has a user ID, but there's 2 IDs. So how do we figure out that out? We can put the table name dot. So address dot ID, and actually that's supposed to be user.id. And so now it knows that it wants the ID from the user table, because you see in some cases they are definitely not the same. Okay, well that is fine. That where clause made that work because now this ID corresponds to that user ID. But for joins, we want to do something a little different. Instead of a where clause, we want to say on. Why do we do that? It's a more efficient query. So the where clause happens after all the joins happen. So if I had, let's say, 100,000 rows in each table. Well, it's going to join them all together like we saw in this top query here, and then it's going to do its filtering on it, on the where, which is it's going to run over several billion rows. Actually, might be like, I don't even know, 100 billion rows, something like that, 10 billion. It's a lot of rows. That's a ton of rows to process. If we do the on, what happens is this runs for every row as it's going over them. So the resulting data set is only 3 rows rather than 6. So it's just more efficient to do the on first because it means that SQL kind of front loads that check and has to run over less data. So your query is going to be faster. If I run that, you can see I get pretty much the same result. So join basically takes another table and smashes the rows together. If you use the on, that can filter it down to making sure that these two things match or don't match. I mean, you could do a not equals as well. That would do something like this. You can see it's kind of the opposite. I don't know why you'd really ever want to do that. So that's a join. This is an inner join, I believe. So let's test. So if we make another user that has no addresses, okay, let's add Tom into the mix, okay, and we run our previous query. Okay, so we see Tom shows up here a couple times, and that's kind of interesting. Why is Tom showing up for these? Join address on user ID equals user.id. Well, Tom shouldn't be showing up for that because that doesn't match. Okay, we got Tom in there. And yeah, so the system doesn't really seem like it knows how to filter him out, does it? That's fun. And that's probably because of the join that we're doing. So let's take a look at our joins again. It looks like we're probably doing a left join here or something along the lines. Let's try some of these joins. What happens if we do an inner join? If we inner join on address. Let's see how these results change. Oh, well, there we go. That got rid of Tom. Why did that get rid of Tom? Well, because the inner join only has rows that where there's something A and B, and Tom has nothing in the address column at all. So that is going to be cutting out that A. So this part is Tom. What we had before is, I believe, a left join, which has the Tom and it has this. So let's see if we do a left join instead. Oh, now we have Tom as null. Interesting. This is kind of what I would expect to have, right? Because Tom doesn't have any addresses, so Tom just gets a null result. It still shows up here, but he's null. Okay, so that's what a left join does. What if we do an outer join? What does that do? Oh, it doesn't like that. Oh, it has to be a full outer join. Okay. Full outer join. Nope. No, maybe my SQL version just doesn't have full outer joins. Anyway, well, that's a thing. You should be able to normally do that, but for some reason that's not working for me. What if we do a right join? Well, right join, kind of the same as the left join, right? It only gives us stuff that matches. Though in this case, if we had an address somehow that didn't have a user associated to it, that address would also show up here. That's not possible because of our foreign key. So that's kind of what the joins do. So if I do a normal join here, oh, now it's not. I'm suspicious because I ran this before and Tom showed up, and now Tom's not there. Yeah, maybe SQL is caching something. So anyway, those are the different kinds of joins that you can do. Generally, if you do a regular join, that's fine because it only finds, I believe it's an inner join by default, and it only finds data where there's rows in both. If you need to see places and you want to see the users and their like even if they don't have an address, then you would do a left join because that'll also show those. So yeah, and you can see, so that's address. So let's look at if we wanted to do something on the purchases table. So maybe we want to see what users purchased a certain product, okay? Or let's just say what product a user purchased. All right, so let's, from user, so let's start off here and let's join on the purchases table. Okay, so if we join on purchases, we can see we have blah, 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 user ID. So let's do an on user ID equals user.id, just like we did before. Okay, now we only get one row, and that's Bob. So here's the user fields, here's the product or the purchase fields. But now we have to join again. We have to join on the product table. Now, product doesn't connect directly to user. It has to join through this pivot table, which we have the product ID for. So we're going to say product ID equals product.id. So now we've actually gone through two tables here. So let's see what this looks like. And now we can see we have our user, these first two, we have our purchase, and then we have our product. Now let's say if, let's add another product in here. Radio, let's make the radio cheaper. All right. And then let's have, let's say Bob purchased the radio too. Okay, now if I run that same query, which I guess I have to put in here manually, all right. Now you can see two rows, Bob and the product. If I purchase the product a second time, it would also show up here and here a second time because of that. Okay, so now we've got our this, and this. So yeah, let's purchase another computer. Bob wants to purchase another computer. I'm actually going to make this so it's one line so I don't have to keep copying it. All right, so now this computer shows up in here twice. Okay, but maybe we don't want that to show up in there twice. Okay, maybe we want to make it so that we only see the unique purchases that Bob has made. So what we can do is we can group on either the product ID or product.id. So if you group on a column, what it means is it compresses all the rows where that matches into one row. So in this case, let's say group by product ID. And if I run this query, oh, it's not group by clause. Wow. Only full group by. Oh yeah, I've seen this. This is because we've got this user ID and a bunch of stuff in here that's getting confused about. So actually what I want to do is I want to group by user ID, product ID. So what's that going to do? First, it's going to say, okay, all of the users, show them as one row, but also show their products as one row. So this should give me two. You can group by multiple columns. It gets a little bit complicated. Oh, it doesn't like that. It's not like test DB purchases.id. Okay, well, we can close that. Let's just look at user.name and product.name. So you can see SQL gets a little iffy sometimes if it can't figure out what you're trying to do. So now in this case, there we go. What happens if I take out this group by? Okay, now I get this. So if I group by user ID, product ID, what if I just group by product ID? I think it probably, yeah, still throws a fit. What if I just group by user ID? Oops. No, it doesn't like that. It's saying, hey, no, I can't figure out what you're trying to do if you're only grouping by one of these. But if you group by them both, then it knows, okay, here's the rows. It can be a bit of an art sometimes to figure out what exactly you need to group by to get the result that you want. But now you can see here I have my user and here. I could actually probably say user.id and product.id as well. And then you can see user has purchased this. But maybe I want to see how many times they purchased that. Well, in that case, I can say count of star. Oops. And count star normally, if I did a count star normally, it would just count all the rows. But if you have a group by, it counts how many rows went into that group. So if I run this, you can see now I purchased product 1 twice and product 2 once. That can be kind of useful. Maybe I want to see how much I paid in total. So I can use sum of price. Price being a column on the product table. So what that's going to do is for every row that went into that group, it's going to add together all the price columns. And there we go. You can see the computer is normally, that's actually, if these are in cents, that's actually a pretty cheap computer. But you can see it summed it up because there's 2 of them. So that's kind of a quick overview of foreign keys, table joins, and a little bit of group by. Anyway, hope that was helpful, and I'll see you all in class.